small shop owner has bought in the Santa or in any Raitu Bazaar.
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
We are TSWREIS. You are top on the Everest. Congratulations.
I want to be a leader.
A colorful good afternoon to all the dignitaries who are present before of this Mana TV. Hi Sparrows, how are you? This is Hima Bindu from 10th standard. Now I am going to teach you one subject. Before going to announce that subject, I want to tell a story. Let us start our class with a story. Are you ready to listen? Okay. There are 2 friends. Okay. The friends' names are MAT and MAT. Okay. There is a middle person between these 2 persons. That person name was HE. And these 3 persons were studied ICS. Can you spell what is this? Yes, you are right. That is mathematics. So now I am going to teach the subject mathematics. From this I have taken a part to explain you. So before going to discuss about this topic, I want to ask you one thing. Are you ready to give answers? Okay. Do you know what are the operations of mathematics? Yes. Can you tell me how many are there? Very good. 4. Can you tell me what are they? Yes, you are exactly correct. The 4 mathematical operations are addition, subtraction, multiplication and division. So now we are going to discuss about what is division. Shall we recall what is division? Okay. See here. Here this is division, 320 divided by 80. So here 80 is taken as divisor and 320 is taken as dividend. So now we have to see that is 320 is a multiple of 80 or not. So here 320 is a multiple of 80. So now we have to see that how many times this 320 is goes in the 80th table. Very good. 4 times. So right here 4 and now the remainder is 0. Can you tell me why do we call this as divisor, dividend, quotient and remainder? Okay, I will tell here. See, dividend means the number which we are dividing is called dividend. Okay, divisor means the number with which we are dividing is called divisor, and quotient means how many times the number is divided is called quotient. Remainder means the remaining number after division is called remainder. Okay, are you clear about this? Okay, do you know the formula of division? Okay, see here, this is the formula of division. Divisor into quotient plus remainder equal to dividend. Once again I will repeat you. Divisor into quotient plus remainder equal to dividend. This is the formula of division. Okay, so please Sparrows, note down these points in your notebook. Okay. And now I will ask another question. Do you know mathematicians? Yes. Can you tell me some of them? Very good. Mathematicians like Srinivasa Ramanujan, Euclid, Shakuntala Devi, George Polya, Aryabhatta, Bhaskaracharya. Like that we have so many mathematicians from our India and from another countries also. Is it? Okay. Do you know the father of geometry? Yes. Who is he? Very good. He is none other than Euclid. Euclid, he is the father of geometry. Do you know one thing? Here our class is going to be a good class. Do you know our topic? Okay, I will tell. Our topic is a great invention of Euclid on division, that is Euclid divisional lemma. You can see here. Yes, that is our topic today, Euclid divisional algorithm. Euclid divisional algorithm. lemma. Okay, this is our topic. So let us see first of all about Euclid. We already know that Euclid is the father of geometry. So are you ready to listen his biography? Okay, see here. We can see here his biography. You can see this is the picture of Euclid. He is the father of geometry. And you can see another picture also. He is also father of geometry. He is known as Euclid. So let us see his biography. So please Ferris, note down all these points about him. Euclid, he is the father of geometry. Euclid was born within the range of 365 and he was died in the range of 265. Okay, and he was the father of geometry, and he is the person who introduced the geometry in a logical order in the book of the elements. Okay, and here Euclid division algorithm is one of the oldest one in this common use. Okay, and this Euclid division algorithm is appear in the book of, especially it is in book 7 and book 10. Here book 7 it is formulated for only integers, and book 10 it is only formulated for lengths of line segments. Okay, his geometry is known as Euclidean geometry. Euclidean geometry is one of the content of the book. Okay, and it is very important for the elementary, and it is also very important for middle class. Okay, and do you know one thing? Here Euclid also wrote works on perspective, rigor, conic sections, number theory, etc. These are the works of Euclid. Okay, this is the biography of Euclid. You can see here also. Okay, are you note down these points? Very good. So let us see another one, that is Euclid divisional lemma. Euclid divisional lemma. Do you know why I am saying about Euclid divisional lemma before I am going to saying about Euclid divisional algorithm? Yes, you are exactly correct. The reason is Euclid divisional lemma is the base for Euclid divisional algorithm. For example, if you want to construct a house, first of all we should construct the pillars of that house. After that only we will construct the house, is it? So here pillar is Euclid divisional lemma. So first of all we have to learn about Euclid divisional lemma. Do you know first of all what is lemma? Okay, I will tell. Lemma means it is a proven statement used to prove another statement. Once again I will repeat you. Lemma means it is a proven statement used to prove another statement. It is called lemma. Okay, this is lemma, and we have theorem for the lemma also. Let us see what is the theorem of lemma. See here, this is the theorem of lemma. Theorem of lemma is, if there are two positive integers a and b, there exist unique integers are q and r. Okay, and these are satisfying the condition a equal to bq plus r. What is that condition? Very good. A equal to bq plus r, where 0 is less than or equal to r and r should be less than b. This is the condition in Euclid divisional lemma. For example, if you take any two numbers, you can take any two numbers. Yes, very good. For example, you can take 12 and 6. So let us say here a equal to 12, b equal to 6. Okay. So let us apply this Euclid divisional lemma to these numbers. A means here dividend. What is this? A means dividend. B means what? Very good, divisor. Q means quotient. Here R means remainder. Okay, are you clear about this? See here 12. Let us apply this Euclid divisional lemma to these numbers. A means 12. Write here 12 and here 6. Now see the multiples of 6. What are the multiples of 6? Very good. Multiples of 6 are 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 24. Like that we have so many multiples of 6. Is there any number equal to 12? Yes, very good. 12 is there. Then how many times it will go in the table of 6? Very good, 6 times. I think you are two wise persons, is it? Then what is the remainder? Very good, 0 is the remainder. Let us take another example, 15 and 4. Okay, let A equal to 15 and B equal to 4. Okay. Now apply this Euclidean lemma to these numbers. 15 equal to, now again see the multiples of 4. What are the multiples of 4? Very good. 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20. Like that we have so many multiples of 4. Is there any number equal to 15? No, there is no number. Then is there any number near to 15? Yes, it is there. That is 12. Then how many times it will go in the fourth table? Very good, 3 times. So write here 3. Here dividend is 15, divisor is 4, quotient is 3. Then what is the remainder? Yes, very good. The remainder is 3. So here remainder is equal to 3, is it? So here if we see our condition, 0 can be equal to remainder, or 0 is less than remainder means what are the numbers more than 0? Yes, 1, 2, 3, 4, 5, 6. These are the numbers more than 0. So here remainder is equal to 0 and here remainder is equal to 3. And next if we come to here, R should be less than B. Here B means I already told you that divisor. Here what is divisor? Very good, 6 is the divisor. Divisor is 6. And here remainder is 0. And here divisor is 4. Remainder is 3. So here remainder is less than 6 or not? Yes. And here also 3 is less than 4. 3 is less than 4 or not? Yes. So our condition is satisfied. This is the Euclidean lemma. And one more thing about Euclidean lemma is, through this Euclidean lemma, the formation of fundamental theorem of arithmetic is also took place. And this Euclidean algorithm is based on this Euclidean lemma only. So first of all, we should get the clear idea about Euclidean lemma. So Whereas, did you get clear idea about Euclidean lemma? Okay, very good. I think you got everything. So let us see another thing. Now we are going to discuss about Euclidean algorithm, because we have completed that Euclidean lemma. Okay. Now we are going to discuss Euclid divisional algorithm. Okay. First of all, do you know what is algorithm? Do you know what is algorithm? I will tell. First of all, algorithm means it is a series of well defined steps is called algorithm. Once again I will repeat you. Algorithm means it is a series of well defined steps is called algorithm. Here you can see that the definition of algorithm. Okay. And one more thing about this is Euclidean algorithm is appears in the book of 7 and in the book of 10. Okay. And this Euclidean algorithm is one of the oldest one in common use. And this, do you know one fact thing, that is this word algorithm is came from a Persian mathematician. He is known as Muhammad ibn Musa al-Khwarizmi. You can see his picture also here. He is known as Muhammad ibn Musa al-Khwarizmi. Okay. And in fact, even the word algebra also came from his book only. So his book name was Aljabar, Hisab, Aljabar wa Muqabla. Once again I will repeat you. Even the word algebra is also came from his book only. The book name was Hisab, Musa, Aljabar wa Al Mukabla. This is the book of his name that he wrote. Again I will tell you, he belongs to Persian and he belongs to 9th century. Okay. Now I already told you that it is a series of well defined steps which gives a procedure for solving a problem, that is called algorithm. Okay. Now see the well defined steps for this. You can see here we have 3 steps to solve this problem. And one more thing about this is, this Euclid divisional lemma is the one of the best technique to compute the value of HCF. Value of HCF of 2 positive integers. Okay. Let us see what is the first step. Here the first step is we have to apply Euclid divisional lemma to the integers which we have taken. For example, if we take 12,576 and another one 4,052. Okay. If we take C equal to 12,576 and D equal to 4,052, then what is the first step here? Yes, you are exactly correct. The first step is we have to apply Euclid divisional lemma to these numbers so that we can find new whole numbers like Q and R, such that our condition is C equal to dq plus R, where 0 is less than or equal to remainder and remainder should be less than D. Here C is considered as dividend. I all told you before of this. D is divisor, Q means quotient, R means remainder. Okay. Let us apply these numbers to this Euclid divisional lemma. C means here 12,576 equal to, now replace 4,052 in the place of D, 4,052. Now see the multiples of 4,052. What are the multiples of 4,052? Very good. The multiples of 4,052 are 4,052 ones are 4,052, 4,052 twos are 8,104, 4,052 threes are 3 twos are 6, 3 fives are 15 and 3 fours are 12. So I think it is the nearest number to these numbers, is it? So let us take 3 times. Then what is the remainder? Very good, 420 is the remainder. Okay. Now we have applied Euclid divisional lemma to these numbers. This is the first step. Let us see next step. Next step is, if R is equal to 0, then D is the HCF of these 2 numbers. Then if R is not equal to 0, what will happen? Yes, you are right, correct. If R is not equal to 0, again we have to apply Euclid divisional lemma to D and R. Here D means 4,052 and R means 420. So let us apply Euclid divisional lemma to these numbers. Okay. 52 equal to 420. Now see the multiples of 420. Do you know what are the multiples of 420? Yes, you are really correct. The multiples of 420 are 421 are 420, 422 are 840, 423 are 1160. Like that we have so many multiples of 420. Is there any number near to 4,052? Yes, it is there. Then how many times it will go in the 420th table? Very good, 9 times. Then write here 9. Then what is the remainder here? Very good, the remainder is 272. Okay. And here also remainder is not equal to 0. Then what we have to do? Yes, you are exactly correct. We have to apply Euclid divisional lemma to this R and D. Here what is D? Very good, 420. And what is R? R means remainder, 272. So again we have to apply Euclid divisional lemma to these numbers. So write here 420, here 272. Now see the multiples of 272. What are the multiples of 272? Very good. 272 1s are 272, 272 2s are 542. So, it is more than 420, is it? So, let us take only one time. So, 1. Then what is the remainder here? Very good. 148 is the remainder. To get remainder here, you have to subtract this 272 from 420, then we can get the remainder. Okay. So, if you observe here also remainder is not equal to 0. Then what we have to do? Again we have to apply Euclidean lemma to these numbers. What are the numbers here? D equal to 272 and remainder equal to 148. Again we have to apply Euclidean lemma to these numbers. Okay. Right here. And now see the multiples of 148. So, what are the multiples of 148? Very good. 148 1s are 148, 148 2s are 296. So, it is more than 272, is it? So, write here only one time. Then what is the remainder here? Very good. 124 is the remainder. Okay. So, let us take again here r is not equal to 0. So, what we have to do? Again we have to take this remainder and divisor also, because here remainder is not equal to 0 na. So, we have to take again remainder and this divisor. So, what is the divisor here? Very good, 148. Friends, are you following me? So, please note down these points in your notebook. Okay, don't forget. 124. Now, again see the multiples of 124. What are the multiples of 124? Very good. The multiples of 124 are 124 1s are 124, 124 2s are 248. I think it is 2 more than 148, is it? So, let us take again only one time. Then what is the remainder here? Very good. Only 24 is the remainder. So, here again if you see here also remainder is not equal to 0. Then what we have to do? Again we have to apply Euclidean lemma to remainder and divisor. What is divisor here? Very good, 124. What is remainder here? 24. Now again see the multiples of 24. What are the multiples of 24? 24 1s are 24, 24 2s are 48. Like that we have so many multiples of 24. Is there any number near to 124 in the table of 24? No, there is no number. Is there any number near to 124? Yes, it is there. How many times it will go in the 24th table? Very good, 6 times. So, write here 6. Then what is the remainder here? Very good, 4 is the remainder. Okay. Now, here remainder is not equal to 0 again. What we have to do? Yes, again we have to apply Euclidean lemma to this remainder and divisor. Here what is divisor? Very good, 24 is the divisor. And what is remainder here? 4. Again see that what are the multiples of 4? 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20, 4 4s are 60. Like that we have so many multiples of 4. Is there any number equal to 24? Yes, it is there. Sorry, here 5. Okay, 6 times it will goes. Is it? 4 6 are 24 or not? Then what is the remainder here? Yes, you are exactly correct. Here remainder is 0. So, here we got the 0. So, let us see what is the third step. The third step is continue the process till you get the 0. It is the third step. So, here we have also applied third step here. That means we have taken again, we have continued the process till we get the 0. So, here we got the 0. So, let us stop our procedure, because here we got the HCF. What is HCF here? When we got the 0, in this stage the divisor will become the HCF of these two numbers. Again I will say, here if 0 is come here in this stage, the divisor will become the HCF of these two numbers. Okay. So, let us see again, here 4 is the HCF of 24 and 4. 4 equal to HCF of 24 and 4. I will write here clearly. Four equal to HCF of 24 and 4, and here 24 and 4 are the HCF of 124 and 24, and again here 124 and 24 are the HCF of 148 and 124, and again 148 and 124 are the HCF of 272 and 148. Okay, and here again HCF of 272 and 148 are the equal to HCF of 4052 and 272, and these two HCF of 4052 and 272 equal to HCF of 12,157, sorry 576 comma 4052. So this is the process that we have to write what is the HCF of these numbers. So these are all equal to one another. So shall we say that 4 is the HCF of 12,576 and 4052? Yes, exactly we can say that because these are all equal to one another. Okay. Friends, did you got clear here about this? Okay, very good. So let us see another example of Euclid divisional lemma algorithm. See here, we can see that we have taken 550 and 300. So here 550 is the bigger than 300. So let us, what is the first step here? Very good. Applying Euclid divisional lemma to these numbers is called the first step. So let us apply Euclid divisional lemma to these numbers. So if we apply here 550 equal to 300 into, if we see multiples of 300, 300 1s are 300, 300 2s are 600, 300 3s are 900, like that we have so many multiples of 300. Is there any number equal to 550? No, very good. There is no number equal to 550. So let us take nearest number to this number. Then what is the nearest number? Yes, 1. So means 300. So write here only one time. 300 1s are 300. Then what is the remainder? Very good. 250 is the remainder of these numbers. So here remainder is not equal to 0. Then what we have to do? Yes, very good. We have to take again 250 and 300 because remainder is not equal to 0. So we have to apply Euclid divisional lemma to D and R. So let us take again. Here the biggest number is 300 and smallest number is 250. So again we have to apply Euclid divisional lemma to these numbers. So if we apply here, what are the multiples of 250? Yes, you are absolutely correct, Svero. 250 1s are 250, 250 2s are 500, 250 3s are 750. Like that we have so many multiples of 250. So if we see here, is there any number equal to 300? Very good. There is no number equal to 300. So shall we take only one time here? Yes, we can take. So 250 1s are 250. Then what is the remainder here? Very good. 50 is the remainder. So here also we didn't get 0. So remainder is 0. Remainder is not equal to 0. Again what we have to do? Yes, we have to apply Euclid divisional lemma to this divisor and remainder. Here what is divisor? Very good. 250. And what is remainder? 50. So again apply Euclid divisional lemma to these numbers. If we apply here, what are the multiples of 50? Yes,